Now let's talk a bit about enterprise applied AI. Now, this is a slide that's primarily focused on just showing how I've seen enterprises adopt AI. This is not meant as a set of, strong fundamental rules that people need to follow. Thus far, most enterprises that want to explore this kind of paradigm start with host selection. What that means is they want to know what ecosystem and what cloud vendor or on-prem vendor should host their foundational models. Many of you are used to ChatGPT. That's generally hosted on Azure. Google, Bard has their own version. There's a bunch of other ones. Anthropic has a hosted model. So first and foremost, the selection criteria of picking where and what technology hosts the foundational model. That's critical. Second comes the selection of the model. While it may seem like a lot of these models operate fairly similarly, each model has a distinct advantage based on the information it was trained on and the weights that it inherently has. This means certain models are better in certain tasks. Many of you may have seen that GPT-4 actually outperforms GPT 3.5 or 3 pretty substantially on a variety of tasks. There are new models that have come out that are particularly good at, as I mentioned, SQL generation. There's even models that can compile fully runnable Python. The second step is once you've picked the host, generally the model comes next. And that's anything from requiring business-specific compliance requirements for your model to even particular goal or use case. Third comes customization. This is a critical piece that involves incorporating your business data into one of these models. And that can mean anything from the technologies that we're going to talk about soon. Finally, there's a step that involves model evaluation and reevaluation. The reason that I broke it into this framework is not just because this is what we've seen enterprises use, but because this is actually the framework that you should be thinking about, or at least the considerations that you should have when working with any of these enterprise foundational LLM models. One of the big challenges that we're going to see is the proliferation of these models, not just in the cloud sense, meaning different cloud areas, but the exponential growth of models as well. As models get bigger and more unwieldy, how can you actually work with these models in a meaningful way? All of these pieces fully inform how well an enterprise can use generative AI. Let's break this down. Each step, as we mentioned, starts with host selection. These slides are a bit heavy on text deliberately to be used as a reference. I'm mostly going to be talking through the high level, and feel free to ask any questions or refer to this in the future. There are generally two kinds of host selections in specifically the engineering landscape for these models. Self-hosted models, which are generally community-driven models that have the weights publicly available. Examples of this are things like Databricks' DALL-E or Facebook's Llama. And there's vendor-hosted models, which is a model deployed by a third-party vendor outside of the direct control of your enterprise. Each has their own positives and negatives. Generally, with self-hosted models, your organization, if it's deployed on-prem especially, maintains control over all aspects of the infrastructure: networking, storage, compute. The setup is completely flexible and customizable. That can be very powerful and very beneficial for an organization that has the existing skill set of managing LLMs internally. However, if that's a very unreasonably high overhead, it gets even worse. Maintenance and upgrades need to be handled by this team. Upfront costs of GPUs, which have been super expensive, licenses, hardware, even redundancy and failover can get prohibitively expensive. But by having all of the information and model under your control, the data also lives in your ecosystem in your control. You may have seen information about ChatGPT accidentally leaking information that somebody trained in it inadvertently. Those risks don't exist in a self-hosted model. The counter side, you have the vendor-hosted model, a ChatGPT, for example. These generally offer higher scalability, as you can pay someone to offload this. You can offload system maintenance, security patches, upgrades, whatever really. And all you generally do is pay a subscription fee. Unfortunately, This means all of your data, query, and sensitive information leave your enterprise enclave and go somewhere else. That can normally be fine, or it can be incredibly problematic if for some reason one of these models get hacked, information gets leaked, or a plethora of other things that can go wrong. Selecting a host is an incredibly important part of developing and operationalizing LLMs. These are the two general criteria. Once you've selected a host, you select a model. I want to be very clear. There is no best model. Anyone who tells you that is wrong. Selecting models at this point is an art rather than a science. Depending on your use case, there can be a number of considerations, specifically models that output code versus models that output English language can be substantially different. So the question of model selection really comes down to a few considerations. First, does your choice of model match your use case? If you're doing code generation, you probably should ensure that the models that you're using are well suited for code generation. If you're generating marketing content, you should make sure the model that you choose is probably suited for marketing content generation. Next, in the realm of data privacy and compliance, what information does your model need to be effective? Can your model use data that your enterprise has collected internally? Does it need external data sets? Does it actually need a completely different way of parsing text and parsing information than has existed before? Are you using a proprietary file format that may make it very difficult for external models to read your data? Third, accessibility. Does your model, language, or anything, does it work in a language and an environment that is appropriate for your use case? Meaning, in the core language that your team works with or your customers work with, is your model actually accessible? We've seen a lot around prompt engineering that can generate very powerful models, but if you're generating a prompt or the model isn't usable by the team, it's not adding any value. Fourth, resource requirements. What are the actual resource requirements from the model's perspective for using the model to the best of its own abilities? And does this work with your infrastructure? Finally, and I say finally because this is the last on my slide, but there's a ton of considerations. Does the model respond quickly to requests? One of the big advances of the large-scale LLM ecosystems that we've seen are the fairly powerful performance of some of these models. They're very responsive. They're not very responsive. So does the model respond quickly to requests? Once you've selected your model, we'll talk a bit about customization. Now, to customize your model, there's two predominant methodologies. First is fine-tuning. Now, a lot of people describe these very wrong, so I'm going to be as appropriate as I can be in the description of these. In the fine-tuning approach, the way that people talk about this generally, an existing model is retrained to incorporate additional data, meaning the weights for an existing model change as a part of the fine-tuning process. So starting with a foundational model and fine-tuning that model is generally the expression that you hear. A fine-tuned model has fundamentally different weights, in most cases, than the foundational model it is found fine-tuned. Fine-tuning is especially good for task-specific performance. It's really good at saying, I have a particular goal, I'm going to refine my model, giving it more cases and more information to accomplish a goal pretty well. It tends to be less resource-intensive than training a completely new foundational model. And again, the model itself is modified. One of the big challenges of fine-tuning is it can lead to overfitting, which may actually decrease the performance of the model. Fine-tuning involves taking a model, you can think of it as almost taking a track changes in Word, taking a document and adding more information and accepting those changes and generating a new document or a new model. The output of fine-tuning is a new generative AI model. Now, the other alternative is what I call RAG. The world calls RAG. RAG is Retrieval Augmented Generation. The best way to think about this is if you look at a window in ChatGPT and you take all of the chat conversation you've had thus far, if you chat with it long enough, you will actually exceed the context window. That is the in-memory of the model. It's the amount of information that the model can remember as a fundamental part of this process. So in RAG, you take business-specific data and you load it into the memory. You never modify the foundational weights of this model. The model, once it's interacted with, is reset, almost as though the memory was never seeded with that information. The primary challenges with RAG are this context window length. There's only so many tokens that can exist in the memory of a model. It can only remember so many things. So once you've exceeded that, you generally use sources like an external vector database or an external store to add and augment more information than fits in the memory of the model. Again, it doesn't change the foundational model. This is the predominant way we see businesses adding data to their models. And I use that in a kind of an interesting phrase because adding data just means they're interacting with a foundational model through the lens of their business data that's been added to the context.